Hello everybody, welcome back, and we're going to be continuing our discussion about systems of equations today by talking about how we're going to solve systems of equations without having to graph. So substitution is one of the two main methods for doing so, and honestly substitution is also my personal favorite method for doing so, so I'm biased. This is going to be fun. So first, what is substitution? Substitution is a method for solving systems of equations by using a variable with a coefficient of 1. That seems pretty weird. Don't worry, we got our rules/steps box going. So, steps. Isolate a variable. We're going to call this variable v1, just for now. 2. We're going to plug in the equivalent value into the other equation of v1. 3. After that, we're going to be able to solve for v2. It might seem kind of distant and far off, but after that step, we should be able to solve for v2. Step 4, plug v2 back into any of the equations we have so far in order to solve for v1. After that, both v1 will be solved here and v2 will be solved here, so we will have our solution. Let's dive in and see some examples in work so we can really understand what's going on. We have our two equations, equation number 1 and equation number 2 here. If you notice, they are not yet in slope-intercept form, but that is okay for now. It doesn't need to be. Now, step 1, we need to isolate a variable, v1. Pick whatever variable you want. Here, I chose this variable, this y right here, because it's going to be easier to solve for that. It has no coefficient. We don't have to worry about dividing. We just need to move some things on each side. So we isolated this y, which is v1, and we got y to be equivalent to 6 minus 2x. Step 2, plug in the equivalent value into the other equation. The equivalent value of v1, y, is 6 minus 2x. So we're going to plug that into the other equation, equation 2, for y over here, right there. So now we're going to be able to solve for v2, which is x. v2 equals x. So we're plugging that back in, and now we're solving for our v2x. 4x plus 4 times it by the whole value of y that we had equals 8. We're going to do our algebra. Y'all should be experts about this by now. And we get that v2, which is x, is equal to 4. Fantastic. Step 3, solve for v2. Check, that is done. v2 is solved. Step 4, plug v2, which is x, back into any equation to solve for v1. Let's plug it back into this one. Let's plug it back into this equation we had right here, because then y will easily be solved for. Again, there's no coefficients or anything. But when I say any equation, it could be this one, this original one we started with, it could be this one on this side, and it'll be okay, or it could be this manipulated one that we had after step 1. So I'm choosing this one. We're going to plug x equals 4 back into x over here, and we get this part. Y equals 6 minus 2 times 4 right here. So y equals 6 minus 8, and y equals negative 2. Therefore, our solution is right here. We have x as 4 and negative 2 as y, and there is our solution. That's a lot, so we're going to do another example before we start some of our own. Also, just like we said last time we were solving it graphically, you can always plug back in our solutions to go and check if it is correct. But we don't have to do that right now. It's beside the point. Example number 2. Well, let's go back to our steps. Isolate a variable, v1. v1. Let's choose 3x. This time is v1, or rather x. So we're going to have to isolate x. So we do our algebra, and we get x is equal to 6 minus 2y. Step 2. Plug in the equivalent value into the other equation. So we're taking x equals 6 minus 2y, and we're putting it into this equation right over here. Step 3, we're going to solve for v2. Now we're going to solve for v2, and over here, y equals v2. Cool. Solving for v2, we get v2 as y equals 6. That's step 3. We've solved for v2. And look over here, don't forget, we have our secret ones over here when isolating y. Never forget the secret ones. Step 4, we're going to plug in v2 back into any equation to solve for v1. Over here, once again, I chose the manipulated equation of the 3 that I got to choose right here, because then we can easily already have v1, which is x isolated. No more manipulation needed. We get x equals 0 as our value for v1. Therefore, here is our solution, this coordinate. At this point, the steps should start to make sense to you, and after the end of this lesson, you'll be able to rattle off the steps immediately, or not even have to say it, just dive right into the question automatically. Okay, let's start some questions of our own. This is going to be a slightly longer video, as you can see. We're already 6 minutes in, and we're just starting our problems. So, first, let's choose a variable to isolate. Let's choose a v1. Some people might go originally for the x to isolate. However, if you look deeper into the equation and try to anticipate one of the further steps, you're going to end up with a fraction eventually when you have to divide divide an odd number by 2 over here. So let's not do that. Let's choose perhaps x. Let's make x on this side equal v1. So we're going to have 4x equals 12 minus 8y. Divide each side by 4, divide by 4. X is going to equal 3 minus 2y. Fantastic. Step 2, we're going to plug v1 in over here to solve for v2, which is equal to y. Great. So now we have 2 times 3 minus 2y plus 3y equals 6. Distributive property. Remember, we have our distributive property. We're going to distribute the 2 to every value inside the parentheses. So now we have 6 minus 4y plus 3y equals 6. I think at this level of the algebra, we're going to be able to start to see elements of everything else that we've covered in previous videos really come into play. Because right now we're doing the distributive property while keeping in mind secret ones. Now we're going to combine like terms over here. So at this level, you're really going to have to start remembering everything that you've covered before. Okay, back to the question. Combining like terms. 6 minus y is going to equal 6. Is that correct? Yes. So we're going to have minus 6 on both sides. Negative y is going to equal 0. Y is going to equal 0 regardless. Let's just make sure I did that correctly because I feel weird about it. 3 minus 2y. 6 minus 4y. Sorry guys, one sec. Okay, that looks right so far. We can check this one to plug it back in just to see if I mess up anything. Okay, step 3 is done. Check. Now we are going to plug this back into this equation, or any equation, to solve for v1. Let's change colors one more time just so we can keep our steps isolated. X is equal to 3 minus 2 times y, which is 0, which means x is going to equal 3. So we have our solution, 3, 0. Okay, let's try and plug back in our solution into both equations just to make sure we did this correctly now, which I can now anticipate that we did. So 4 times 3, which is x, plus 8 times 0, which is y, equals 12, question mark, well, 12. This part goes to 0, does indeed equal 12. Fantastic. Other side. 2 times 3, which is x, plus 3 times 0, which is y. This part goes to 0 again, equals 6. Well, 6 plus 0 does indeed equal 6. Check mark. We did everything correctly. Let's keep moving. 2x plus y equals 6, and 3x plus 4y equals 4. I'm going to pick y to be our v1, because we won't have to work with any coefficients here. So let's jump in. We have y equals 6. We're going to subtract the 2x and put it over on this side, minus 2x. Step 2. We're going to plug y into this equation to solve for v2, which is x. 3x plus 4, plug in 6 minus 2x, equals 4. Distributive property. 3x plus 24 minus 8x equals 4. So when combining like terms, we're going to get negative 5x plus 24 equals 4. Minus 24 minus 24. Negative 5x equals negative 20. Divide by negative 5. Divide by negative 5. X equals 4. Step 3 is solved. Now we're going to plug x back into this equation. If you guys notice, I tend to prefer to plug it into the second equation that we have, the manipulated version of the first, because it saves us time. But really, it works out either way. In any equation, in case you forget, it makes no difference. Y equals 6 minus 2, and we figured out that x is equal to 4. 2 times 4. Y equals 6 minus 8. Y equals negative 2. So our solution is the ordered pair 4, negative 2. There is our answer. At this point, this should really starting to make sense. We'll do 2 more examples just to make sure you guys got it, because this is a super important topic and actually is used in the next topic of elimination, which is why I prefer personally just doing substitution. You can't do elimination, which we'll talk about next video, without knowing substitution first. So, great. Let us keep going. I'm going to pick this y to be our v1 this time. So, to get there, we have to divide each side by 2, and we get y is equal to 2x plus 3. Step 2. Let's plug this over there and make x equal to v2. 8x minus 4 times 2x plus 3 equals negative 12. Distributive property. And don't forget to distribute the negative with it. Very important. 8x minus 8x minus 12 equals negative 12. Well, these are going to go to 0. Minus 12, negative 12 equals negative 12. What does this mean? Well, here's something really important. I honestly felt like you guys might have gotten the point of substitution after the previous 2, so I'm going to show you guys now with these next 2 questions, including this one, some special examples. When you are substituting and you get something that just ends up to be a true statement of some sort, that means that you have the instance where, is it shown at the top? Oh, it was in the last video, my bad. This means that you have this statement where all real solutions are possible, where basically these are the same 2 lines. True statement. It doesn't necessarily have to be it doesn't necessarily have to be a true statement with 2 constants. It doesn't have to be 6 equals 6 or negative 12 equals negative 12 here. It could be something like x equals x or something along those lines. If you have a true statement, it means that they're the same lines, and the solution is going to be all real numbers. I also want to take time out here to show you guys a new symbol. There's this symbol that looks like a capital R, but with 2 lines. This symbol means all real numbers. When somebody asks you for a solution and you give this sign, it basically means for any numbers x and y that you plug in to the original 2 equations, as long as x and y is the same for each side, for this side, x and y is the same x and y over here, these equations will equal. This is the all real number sign. Super important. Also, if we take a step back and we make these 2 equations into the slope-intercept form, we will see that although they look like different equations right now in their messed up form, they're actually the same thing. So let's just take time to do that. 2y equals 4x plus 6, and then 8x minus 4y equals negative 12. Okay, so we already divided each side by 2, and we got y equals 2x plus 3. Then over here, we will get negative 4y equals negative 8x minus 12. Divide each side by negative 4, divide by negative 4, and we indeed get y equals 2x plus 3. The same equation, hence all real numbers is a solution. Okay, great. If we did all real numbers as a solution for this question, what do you think this one can be? Could it possibly be that there is no solution? Let's see. Let's just start it as normal, as we would do with substitution. We'll pick y as v1 because we can easily divide everything by 3. So then we get y equals 2x plus 4. Cool. Now we're going to go and try and solve for v2, which is going to be x, by putting this over here. 2 times 2x plus 4 minus 4x equals 8. Distributive property, remember. 4x plus 8 minus 4x. Did I do this correctly? Hold on one second. 2 times 2x plus 4 minus 4x equals 8. Cool. So we get the solution again over here, that 8 equals 8, which means, once again, this is just a true statement. However, I want to show you guys an example that's different from these. I want to try and find an example for you guys where we're going to have something that, as I mentioned earlier, is parallel lines, which means there's going to be no solution. So let me just think of one. Y equals 2x plus 4. Then let's have over here 2y minus 4x equals 16. Great. Let's try and find the solution of these ones. So let's choose y as v1. So we already know what it is. We can plug it in over here to solve for x, which is going to be v2. So 2 times 2x plus 4 minus 4x equals 16. Distributive property. 4x plus 8 minus 4x equals 16. These cancel out. 8 equals 16. What? That is not a true statement. That doesn't make sense. And we have no more variables here to work with. When you have a not true statement, and once again, it doesn't just have to be 8 equals 16. It could be, say, negative x equals 2x, which is not true. That means that there are no solutions. These are going to be parallel lines when you eventually break them down into y equals mx plus b. If you see over here, we can take this and go 2y, and now bring the 4x over, 4x plus 16, y equals 2x plus 8. These are parallel lines, hence there are no solutions. So what else can we take out of this lesson besides just substitution method? We can take two things. One, when we're doing substitution method, if we get a generic true statement, that means, therefore, here's one more sign that you guys should know. These 3 dots in a triangle, this means therefore. Therefore, a generic true statement, therefore means that all real solutions, or they are the same line. Look at you guys, learning all this new fancy notation today. Then, if you have a generic false statement, then, therefore, no solution. Parallel. Remember, this is the parallel sign. We talked about this. This is a parallel sign because they are parallel lines. Fantastic. And this is shown in problems number, 3 and 4. And this one is showed in number 5. Okay, so that is substitution method. This is definitely a difficult subject, and you're going to have to know how to master this in order to do elimination, because there's going to have to be some substituting when doing elimination. I hope this made sense. Go ahead and watch it again and slow it down and pause it to really understand this before you move on, guys. See you next time.